Okay, in this presentation we are going to look at a confidence interval worked example. So this is for a single sample proportion. So we're dealing with proportions and we are dealing in this case with a single sample. So let's look through this one. A well-known polling company estimates that 57% of Irish voters support a new constitutional amendment. 800 people were randomly surveyed and asked about their voting preferences. So there we have the sample size. And 482 of the people responded positively to the amendment, which is to say they are going to vote yes. So, exercises. You are required to A. Obtain a point estimate for the proportion of people supporting the constitutional amendment. B. Construct a 95% confidence interval for the proportion of people in favour of the new constitutional amendment. Okay, so let's go to exercise A here. Obtain a point estimate. So this is a fundamental part of working with confidence intervals and hypothesis tests, which you'll presumably see very soon. So the point estimate of the proportion of people supporting the amendment is the sample proportion p hat, and it is calculated as follows. P hat is the number of positive responses divided by the total number of respondents. So the total number of respondents essentially are sample size, and number of positive responses is number of positive cases, positive responses. So p hat is equal to 482 divided by 800, which is 0.6025. So that is p hat equals 0.6025. Okay, so 60.25%. So this is an important part of working with confidence intervals and hypothesis tests. So what we want here is a confidence interval for a proportion from a single sample. Now this is important because in the context of hypothesis tests there is a slightly different formula for this. Okay, so the standard error SE of p hat is the square root of p hat times 1 minus p hat divided by n. Now, just be careful with this. If you're doing hypothesis tests, there is a slightly different formula that is similar but different in one crucial detail. I'll save that for another time. Just to remark that I did actually make and spend time looking at this, so just remark upon that. Okay, exercise B, construct a 95% confidence interval for the proportion of people. Okay, so essentially what you're going to do here is use the formula for confidence interval for a proportion. Now, just as a remark, I just mentioned the standard error formula there, which is on the right hand side. But the general formula for a confidence interval is the point estimate, which is p hat, plus or minus the quantile, which is a critical value from the 95% critical value for the standard normal distribution, okay, times the standard error. So again, point estimate plus or minus quantile times standard error. So p hat is the sample proportion, that's our point estimate. Z of alpha over 2 is the critical value of a 95% confidence level, which is approximately 1.96. Okay, now that's an important thing there. Where does this 1.96 come out of and how does it relate to 95%? That's an important question and worth dealing with in a different video if you're not familiar with it. The second of those 3 bullet points is critically important. I'm not going to deal with it now, but you should become familiar with 1.96 very often when dealing with these sort of questions. Okay, and n is the sample size, 800, the total number of positive cases. So essentially what we're going to do is some calculator work. So just as a remark, what we're going to do is look at the part of the equation that is on the right hand side of the plus and minus. Okay, so I mentioned quantile times standard error. Collectively we call that the margin of error. So we're going to calculate that first. So the quantile Z of alpha divided by 2 is 1.96, so that just cascades the whole way down. Okay, so on the right hand side expression we have the standard error. So the square root of p hat times 1 minus p hat divided by n, that is 0.6025 times 1 minus 60.25 divided by 800. Okay, So 1 minus 0.6025 is 0.3975. So essentially, we are multiplying 0.6025 by 0.3975, the complement, and divided by 800. So we end up with the square root of 0.2397 divided by 800. A little bit of calculator work. It gets very messy a little bit. You have to watch all the zeros. But essentially we end up with the square root of 0.0002296. You will get a lot of decimal places there. It's just one place. You can't really avoid it. Just go to 6 or 7 decimal places. This is one sort of situation where you can't avoid it, and you should just actually do that. Anyway, bit of calculator work. We have 0.0173. So we end up with 1.96 times 0.0173, and that is approximately 0.0339. Rounding error will come into this. So if you have a number that's approximate to 0.039, you're good. Okay. So we end up with 0.6025. That's our point estimate, and margin of error, which is the quantile times the standard error, is 0.0339. So that gives us 0.5686 as our lower bound of our confidence interval and 0.6364. Okay, now, so the confidence interval of the proportion of people in favour of the constitutional amendment is 0.5686 to 0.6364, or in other words, 56.86 percent to 63.64%. The upper bound and the lower bound of our confidence interval. Now, not asked there, but you might notice that 57% is in that interval. So that was asked as part of the question. That's a useful thing to spot. It's not really asked here, but it's very interesting that 57% is in that interval. So anyway, that's sort of leave that for another time. Anyway, the standard error is the key thing there. Okay, we'll leave it there.